welcome to this quick chat, which is part of Laser Focus World's PhotonicsNEXT event. I'm John Wallace, Senior Editor at Laser Focus World, and I'm talking with Denis Boudreau, Product Leader of Photon Detection at Excelitas. Excelitas Technologies is a photonics company that is focused on delivering illumination, optical, optronic light detection solutions to OEMs across medical, consumer products, semiconductor, industrial manufacturing, scientific, safety and security, defense, and aerospace sectors. So very broad. And as I mentioned, Denis Boudreau is the product manager for Excelitas Photon Detection business, which provides emitters and sensors into a wide range of applications, including LiDAR. To start, let me ask you, Denis, if you could say just a bit about yourself, Excelitas, and its line of photonics products.
Certainly. Thank you, John. So as you mentioned, I am the product leader for the detection business, which also includes pulse lasers, by the way, which we'll be discussing today. So we have a long legacy of manufacturing silicon and in-gas detectors, be it pins and APDs. And we also have complementary pulse laser diode technology products that pairs extremely well with these products. So we have quite a broad offering of components, modules, and subsystems that we can offer to the LiDAR range finding and other adjacent markets.
So as far as the edge emitter pulse lasers, what are the overall advantages of Excelitas's edge emitter pulse lasers?
Well, John, as I mentioned, Excelitas has a very long history in this field, in this product technology. We've been around for decades, and we're constantly evolving the offering that we have for the market. This particular product we'll be discussing today is a pulse laser, a new generation that we offer in plastic packaging. It's very cost efficient. It's very well tuned to high volume applications. It's a field-proven design, but we're enhancing it, we're evolving it. It can be seen as an alternative as well for more costly metal can type packages. Gives you very low inductance, enables short pulses to be generated from the laser. And when you're doing range finding in LiDAR, short pulses gives you much better resolution on the accuracy of the range measurement that you're doing. So it's a huge benefit from that perspective. It's also a triple cavity design. So compared to single cavity designs, you have 3 emitting stripes in the laser that's emitting light. So for the same input current, you're essentially getting 3 times the level of power. So you're ranging much further with these types of products. And finally, the technology itself, we mentioned it's edge emitters compared to VCSELs. So what you're getting here as far as major benefits is you're getting an extremely high amount of optical power in a very compact space. So when you're doing your optics design, for example, everything can be made smaller, more compact, less costly. So it's a huge benefit from that perspective. So I would say those are some of the main advantages that we bring to the table as a corporation.
Just a side question. You mentioned it's a triple cavity design. Are the cavities stacked on top of each other? Are they next to each other, or?
They're one on top of the other.
Okay.
Yeah, in a monolith.
Which would make sense. Yeah.
Yes.
So how does the second generation of Excelitas pulse laser diodes compare to your first generation products?
Sure. So what we're seeing from the market is a push towards longer range, more efficiency, and that's really driving our R&D roadmap nowadays. So when we look at the generation 2, I would say one of the main benefits or one of the main breakthroughs and advantages is you're getting a lot more power. So you're getting more than 20% increase in power output when compared to our first generation products. And when we talk about range, there's an immediate benefit of getting this extra efficiency. Alternatively, if you're looking at battery operated systems, for example, and power consumption becomes a critical factor for your system, then you can also derate the current. If you have sufficient power, you just want to consume less, you can derate, get less current flowing through the device, consume less power electrically, but still get the same optical output. So it's really dependent on the system, what you're trying to do, but this new generation really enables you to do both options if you want. And it's also a drop-in replacement for the first generation product. So anybody, for example, that would have been using a generation 1 product has a circuit already built up, can drop in the the Gen 2 part in there and get that extra 20% power and the immediate benefits of the longer range. So I would say those are some of the major benefits that come with the generation 2 design.
What are some of the target applications for these, for the 905 nanometer pulse lasers?
For these parts, some of the immediate applications that can already benefit are in the range finding laser meter space. So here we're not creating a 3D image, for example. We simply have the laser that's emitting a pulse of light, hitting a target, getting that signal back. We also have complementary detectors to detect that reflected light. So here you're measuring distance. So those types of application really benefit from the high volume, low cost, improved efficiency. And these applications, of course, are already addressable today. When we talk about LiDAR nowadays, of course, there's so much talk about automotive LiDAR, ADAS, autonomous vehicle. It's really the buzzword. It really is the future for sure. We're convinced of that. But however, we all know it's some years away into the future. Systems are not rolling out in huge volumes in 2021, though we are looking at qualifying certain systems. However, the real volume will only come later. So what a lot of OEMs are doing in the meantime is they have developed all these great systems for LiDAR, but they're trying to find a market avenue ahead of the automotive space. So they want to ramp up volume, they want to improve reliability, they need an outlet to market. So that's where industrial LiDAR really comes into play. So if you're thinking, for example, about surveying applications, aerial mapping, drone type applications can all benefit from this type of technology. If we think about warehousing, factory automation, factories that can even operate with the lights off, essentially, where you have 3D infrared vision. So LiDAR plays a key role in all of these applications. Safety, for example, or monitoring, you can think about a particular space where you might want to know how many people are in that room, in that space, how are they moving. You can achieve this with LiDAR. And lastly, perhaps, and we're not so sure about this one, how it will take off, but social distancing, for example, is a big buzzword nowadays for obvious reasons. So one could imagine that you would have a system on you that would alert you should anybody be within that 6 feet, 2 meter distance. So hopefully that one's not needed, but we'll see how that evolves. And just to conclude on this one, so we mentioned that it's 905 nanometers. Why is that so attractive? Well, it pairs extremely well with silicon detectors. The peak wavelength efficiency of silicon is around 905 nanometers. So it makes for a great pair. And from a cost perspective as well, silicon detectors are much less expensive than their corresponding 1550 counterparts. So that's why a lot of the systems today are at 905. We certainly see a future for 1550 as well. But for the time given, today, given the constraints on cost, 905 is really the driving wavelength for now. Yeah.
Mm-hmm. So what can you share with our audience concerning what's in store for the future from Excelitas?
Certainly. Of course, as I mentioned, we're heavily invested in the LiDAR space. So a lot of our R&D roadmap is geared and tuned towards that. So a lot of work's going on the chip itself. So we process our own wafers. So the Gen 2 is just the start of that. We'll have subsequent releases beyond that. And we're also looking at different packaging, for example. So we mentioned the plastic package that Gen 2 is available in today, but that remains a through-hole device. On our Gen 1, we have a surface mount device variant of that, which is very compact, very small form factor, and compatible with automatic robotic pick and place tools. So the Gen 2 will be available with this as well. It also has the benefit this one package can be mounted in 2 different ways. So if you need the laser light to emit parallel to your PCB, so parallel to the mounting plane, you can do that. However, if your system requires the light to come up from the PCB, for example, you might have a reflecting mirror that you want to redirect the light with. You can also mount it 90 degrees up in one single package. It makes it much more versatile as a package. We're also looking at arrays. I mentioned arrays earlier. So it is a multi-cavity laser, but you can also do arrays in the other direction as well. If you want to split up your field of view into higher resolution arrays, you can do that monolithically if it's lower pixel counts. So if you're trying to get adjacent pixels very close one to another, you can go monolithic. Or alternatively, you can go in a discrete fashion and have however many lasers as you want in your particular system. So that's also an area we're exploring. We talked about automotive LiDAR. Certainly the reliability requirements are very high. So having the chip is not enough. You also need some packaging technologies as well to go with that. So a lot of development is happening there as well. And whenever you say automotive, of course, reliability is a big thing, but also cost is also a limiting factor. So as we know, typically, historically, new technologies in automotive, they always start with the high-end vehicles, the luxury vehicles, because they can afford, a 5, 10K option on their vehicle. However, for, lower price cars, that's definitely not an option. So as the technology, the volume will mature, costs will come down, and we'll see that deployed on more vehicles in the future. So that's really where we are focused right now and where we see the technology going. And certainly on that, if any of your viewers has further questions, we'd recommend they check us out on excelitas.com. We have the product section that talks about lasers. We have the application section that talks about industrial LiDAR. And of course, they can always send us emails at photonics@excelitas.com. We'd be happy to discuss with them their unique needs for their application.
All right. Well, on behalf of Laser Focus World, I'd like to thank our guest, Denis Boudreau of Excelitas, for joining us at this PhotonicsNEXT event for the informative quick chat we just held on pulsed laser diodes.
Thank you very much, John.